What's that?
Nothing.
Oh, thought you had something to say. You guys are super quiet. Is it too early? 8 o'clock's too early. I'm with you. We should have this window from 9 to 1. Maybe I'll work on that. Hannah, you ready to go? Bobby, you ready to go? What are you guys talking about? Candy?
Glow in the dark. They don't glow in the dark. They
Irradiate?
yeah, you can see them in the dark if you shoot them. Looking at a mirror in the dark. Do it.
Do they spark or something?
That's really weird. It's kind of cool.
You should put it up on your YouTube channel. Yeah, right. Flanagan's Challenges. Isn't that what they call that? Challenge videos? You're a challenge YouTuber? Okay. So we're going to talk about this. This is Michael Cooney's genetic results for genes that have been suggested or evidenced to be associated with fitness, training, and nutrition adaptations. So this is the manifestation of Cash and Michael's spit. And we sent that to a lab, and the lab sequenced these genes. So what the lab is doing is they take some of Michael's spit, they isolate the DNA out of it. The tube that he spit in actually had a chemical in it that stabilizes DNA, but lets everything else degrade. And that functions at room temperature, which is how, or across a variety of temperatures, which is how DNA is very stable. This is why, in CSI, they can find a drop of blood that's 2 months old or whatever, or they can go back and, do you understand what I'm saying? Yeah, so DNA is quite stable. So this is good. Now, what this doesn't tell us are things like his epigenetics, whether or not these genes interact with each other in different ways, and all these different types of stuff. So even though this seems like a lot of information, and it is, and important information, which it also is, there's still limitations. So we're going to talk about what you can do with this sort of stuff. Okay, so the first thing that we need to look at is the fact that basically they are looking for the presence of particular single nucleotide polymorphisms that are associated with different characteristics that are related to sport and exercise. Single nucleotide polymorphisms, of course, are these individual changes in nucleotide sequence that alters the expression of the gene or the product of that gene. All right, so for instance, there's typically this never mind. The example I was going to use is not in here. Okay, so one of the things that we can go through now, when people express certain gene variants, then those genes are related either to differences in protein expression, or they regulate other characteristics like changes in nutrient absorption, changes in the production of certain hormones, or all these different types of things. And you can take those things into consideration and apply them. Now, one of the things that fitness genes in 23andMe, and there's another company called Pathway Genomics, which is quite good. One of the things that they do to scale this up and make it applicable is that they try and interpret studies that are a lot of times associative studies, right? So, for example, the bonus article from, I think, week 1 or week 2 in this class that I post each week along with the material, which I'm sure all of you read thoroughly, is about genetics in sports performance and sports injury. And that's a really nice review article that summarizes a bunch of studies that associate changes in certain genes or certain SNPs to certain characteristics. So, for example, there's this gene called the MMP something. It's metalloprotease gene or something like that. And it's involved in the braided structure of collagen. And so when you have a certain SNP, it can alter the actual physical outcome of the structure of your collagen. So instead of having a tri-braided structure, you end up with a di-braided structure. And the thought was, well, maybe people with this have compromised ligament strength and maybe they're at increased risk for injury, right? So they went back retrospectively and took tissue from people they went back retrospectively and looked at things like soccer players and rugby players and other people that had torn their ACLs or had Achilles injuries. And then they took tissue from those individuals and sequenced them to find out if there was an association. So this is what I mean by there's retrospective and they're associative. So they're not saying necessarily this is exactly why this individual got injured. They're just able to show statistically that the people that were injured playing the same sport and participating in the same training, similar training load and similar games and activities and things like that were whatever this much percentage, 20% more, 30% more likely to get injured. Do you understand? So it's really important to take these things into context when we're talking about it, because when you're looking at one gene and you're looking at one characteristic that's associated with that gene, there may be a strong correlation or even a moderate correlation between some sort of outcome, but it doesn't guarantee that that outcome is definitely going to happen. Do you understand? It's really important to understand the limitations behind this. Because what you'll hear is people go like, well, I have this or I have that or this, and it definitely means this or that. And it's just what you need to think about from a practitioner standpoint or a coaching standpoint or a trainer standpoint or even a health coach standpoint is, all right, we're going to take these things into consideration and I'm going to be aware of it. And I'm going to monitor things maybe a little bit differently or make sure that the muscle structure around at-risk joints are really in good shape. I'm going to change a prehab program based off something that could be something that I know that may prevent an injury, right? But then it's also important to track your injury incidences, the conditions under which injuries are taking place, training or in games, all these different types of things over time so that you build up a database of understanding in regards to how this type of information can be used and applied. Does this make sense? All right. So what they do, some of them are black and white, right? We know what the gene is for the lactase enzyme. So if you don't have it, then you're lactose intolerant. You don't, that's just the way it is, right? It's pretty interesting because you would think, here it is, the LCT gene. You would think that somebody would know that they were lactose intolerant, but 2 years ago when we did this for the lab, the person that did it was homozygous for lactose intolerance and had no idea. She's like, oh, that's why I always get an upset stomach after eating pizza. And it was I found that interesting. So to some degree, it's a good reminder that we sometimes ignore things our body is telling us. And we could potentially benefit from being more aware of that. All right? Okay, so there's different levels of applicability, there's different levels of information, and there's different levels of meaning and association with what these results mean. The other thing that's interesting is that as these get bigger and bigger, right? So what I told you 10 years ago, you would get one gene, and you would get tested for the ACTN3 gene, and then you would be told if you were a strength athlete or a power athlete, right? Now we're looking at 48 genes or 45 genes or whatever it is. I didn't count them up, but I know it's somewhere in the 40s. And we have to think about, all right, how do all these different characteristics interact with each other, right? And this is even a very limited number of genes. These are just genes that are somewhat well established and can be backed up with literature in regards to their association with certain characteristics. There's so many other, right? There's a lot of genes. And there's a lot of combinations of a lot of different genes, right? So one of the things that companies like Fitness Gene and 23andMe and Pathway Genomics are trying to do is scale this up so that they can just take information and create algorithms where different combinations of different genes provide different groups of recommendations, right? This is how you would scale this up. So one of the things they've done for Michael's genes, is that you can sign up for all these nutrition plans and fitness plans and stuff like that, and that's how they're going to make a bunch of extra money, right? Because you don't need to keep getting your DNA tested. You know what it is now. But what you can do is buy their algorithms that say this is the way you should train based on your genetic profile. But we, and you all, have had the opportunity to take EXS451. You're critical thinkers. You understand this material. And so what you can do, and what we ordered, was just the straight DNA test with none of the other additions, right? No nutrition program, no training program, nothing like that. And what we can do, because we have this background and this training and this experience, this highly applicable and relevant experience in our modern, fast-paced world, we can look at this and start to come up with some ideas about how you would use these sorts of things, right? All right. And this is out there. I mean, I have athletes get in touch with me and say, like, hey, this company reached out to me and they wanted to do genetic testing. Can you look at this? What are the implications? Is there anything we need to change? Those types of things. So, I mean, it's out there. And some of it, I think I've told you the story about the woman that did the interview with like Outside Magazine or something like that, where she was saying, yeah, it was great for me to find out that I have issues with Achilles tendinopathy, and she'd missed like probably 25 international races over the last 5 years because of Achilles injuries. Like, you don't need this to tell you you have Achilles issues. You see what I'm saying? But if you're talking about young athletes, if you're talking about people just entering a college program, if you're talking about people that are trying to optimize their health and wellness, then you can use this sort of information and try and you can use this information, and then it can influence some decisions. Now, one of the things that Fitness Genes has started to do is they actually do plug, even if you just get the straight DNA analysis, they plug it into one of their algorithms and they get some information. So for example, if you just go to this U tab, you see DNA results, and that's the page we're on now. And it's just a straight list of what those results are. In the workout section, it doesn't give you like a workout plan, but it gives you this list of personal insights where they've taken certain gene markers that just mean certain things, and you can start to get an idea and a summary of some of the characteristics of the outcomes that Mike had. And this is actually can be useful, especially when you're just trying to summarize and get used to doing these types of things, right? So things like you have great recovery between workouts, you can train more often. You respond well to low and high number of sets in a workout. You have moderate rest periods between sets. So see, like you can already start to put together some sort of story in terms of training load and programming within workouts just from these certain characteristics, right? All right. So then there's also some information about nutrition. So it's interesting because we now have genetic markers of metabolism. Metabolism is highly regulated. There's a high genetic influence, that genetics play a role in determining metabolism, right? So that's important. But also your height, your weight, your age, your gender, all those types of things, right? So they have some basic daily macronutrient composition. These are based on percentages, which I don't love, because if this changes, then your total amounts of macronutrients would change because you're worried about a percentage. So, you can use this or not use it. It's not that, I don't think this is really all that beneficial. But you have a bunch of information. You can tolerate high glycemic foods. You can tolerate lactose. You get benefit from certain fatty acids based on some genetic profiles that you have, and some of these other interesting things, like it's okay if you skip a meal. You're not at risk for overeating later on, right? And these are insights that come from studies. They don't give you a lot of information here. But these are insights that have come from studies where they've looked at the impact of meal skipping in under different conditions. Mar, you doing okay? Where they've looked at who's at risk for overeating, who's at risk for these types of things, right? And it is pretty interesting when we look at this. Has the potential to tie into other studies and other things that we've seen with people that, say, have a difficult time regulating their weight. So one of the things that a colleague of mine published some papers on when he was a PhD student, he's gone on now to, he's a big shot at University of North Carolina, Chapel Hill, and he does studies looking at how different people's brains process different food cues under different circumstances. So, for example, if you feed somebody enough calories that they should be full and satisfied, and then you show them different pictures of things like chocolate cake or, different things like that, some people's brains, their desire center of their brains just go crazy and light up, and would make it really difficult if that food were present to not eat some of it, right? Whereas other people just have no desire for that at all. Super interesting, right? So that's genetically modified. That relies on genetics, it relies on epigenetics, it relies on other habit formation and different things like that. So it's super complex, but some of these things are potentially associated with overeating if you miss a meal, compensation, those types of things. And these connections are being made. Right? So because Michael has taken EXS451, he knows how to read literature, he can understand some of these things at a basic level. His genes aren't going to change, but what is going to change in terms of our understanding? More and more what are going to come out? Studies. More and more studies are going to come out. And so as more and more information is produced, once a year or once every 18 months, he can go in and say what types of review papers have come out characterizing the impact of new genes and our understanding of those. Not new genes, our understanding of genes, particularly ones I've been tested for. Right? So the first year we did this, it was my first year here, so it was fall of 2013. We, I think, paid almost $400 to get 10 genes, and it was pretty limited in scope in terms of the application and kind of full understanding of how to use it, right? And there weren't a ton of companies out there, and the companies that were out there were just getting started. We actually used Pathway Genomics that year. Now, fast forward to 2018, only 5 years later, for $199, we got 45 genes and a bunch of really usable information. And that's the way this is going to keep going. But you have to temper your expectations with it, right? Okay. So, a couple things that should look familiar. ACT and 3. Yeah, Trace.
So, you test out for like 40-some genes, and it says, you said that like these 40-some genes like associate kind of with like exercise.
Yes.
So was there like different options to choose from besides just like...
Kind of, yeah. So there are there's a number of genes that can be tested for disease risk, but they can only be ordered by your physician. So you can't like voluntarily order them to get them. And in fact, there was just something that got passed by the FDA that was a big thing that 23andMe was lobbying for, which was like to expand it to certain genes that indicate risk for certain diseases that may not have some of the like mental impact on some people and there are certain genes where you can't be told what you have until you meet with a genetic counselor. So there's this whole new field of counseling called genetic counseling. It's a master's degree that you earn. Super interesting job, in my opinion. And basically, if you can't just tell like an 18-year-old that you're definitely going to get Parkinson's or something like that, right? That's a big thing to try and deal with and unpack at that age. And so for certain genes that come with certain risk, you have to meet with a genetic counselor and talk about what the implications are, what this means, how to unpack it, all these different types of things. And that's when you have the opportunity to talk about things like genes are just genes. They're not. It has to take into account the environment, has to take into account all the studies that have been done. Here's what the chances are. Here's the characteristics of the people that end up developing this or don't end up developing that. So there's might be some things you can influence. So yeah, there's a bunch of other genes, right? The other thing that we do for this is like, say an individual develops cancer. And so that cancerous tissue is going to arise and take on the characteristics of cancer tissue as opposed to healthy tissue, right? And in order to be cancer, it has to have mutations to its genetic code. So it's common practice now when somebody gets cancer is to biopsy the tumor and then genetically analyze it for common mutations. Because we know that certain cancer drugs, certain chemoradiation, certain nutritional approaches, those types of things, more greatly affect different types of cancer in different ways. Do you understand? So, in fact, have you guys heard of like immunotherapy? Just in the news and those types of things. So this is a new way of treating cancer where you basically, tumor cells, because of their genetic mutations, express things on their cell surface that normal healthy cells don't. And you can manipulate an individual's immune system to recognize those differences in characteristics and then get your own immune system to attack cancer and kill it. It's like you give yourself an autoimmune disorder against the cancer cells, basically. It's like a vaccine, sort of. Does that make sense? So like if you have a cancer cell that expresses this cell marker that we know only exists in cancer cells but not in normal cells, then we can inject a drug that ramps up your immune system and gives you an antigen to recognize this as a foreign thing. Because one of the tricks that cancer does, for example, is it basically has the ability to play Jedi mind tricks on your immune system cells. So the immune system cells are always circulating through your bloodstream, and they're always looking for things that don't seem right? Things that are out of order. And cancer has developed the ability to go like, no, move on, nothing to see here. And it evades. And a lot of early cancer and a lot of early issues with cells and things like that are recognized by our immune system and killed by our immune system before they become an issue. But it's the cells that develop mutations that allow them to evade our immune system. So if we can if we can mark them, if we can make them marked people, then our immune system can attack it and kill those people, right? So in fact, there was a drug 2 years ago, it was in the news, that got approved by the FDA for treatment on cancer, and it was the first cancer treatment to ever be approved based on a genetic marker, not on the type of cancer. Do you understand? So it doesn't matter what type of cancer the person has. If they take that tumor, if they take a sample of that tumor and test it and it has this particular genetic marker, then you can get this drug that we know attacks that type of marker. It doesn't really matter what the cancer is. Super powerful, right? That's really powerful. So yeah, good question, Trace. There's a lot that we can, and I mean, the databases for these things are massive, right? So I mean, you may test a tumor for 300 different genetic markers that we know are associated with different characteristics. And then you have algorithms that say, yeah, we got this certain combination that we know responds to these different things. It can be really powerful in treatment planning. Understand? Okay. But we can apply those same principles to things like health and wellness to try and maximize people's response to health and wellness. And that's what we're kind of getting here. Okay? So ACTN3, that should look familiar. That's the quote-unquote speed gene that we talked about yesterday, right? So what's quite cool is you can look at this, and we talked about the C is associated with the R allele. So we talked about it in terms of RR and what? What was the other allele? What? XX, right? So the presence of RR, which is the presence of RX or RR make up the majority of individuals, right? And we said that. We said that in a slide yesterday. 82% of individuals are either RR or RX. And there's RX in every category across that span. The only thing, there's RR and RX across every category in that thing, right? The only thing that would preclude you, based on that one study from being an Olympic weightlifter, is if you were XX or what they're calling here TT. Do you understand? But what does 38 and 44 add up to be? 82, right? That's what we presented. So the studies that our book is using to write the textbook are the same studies that these people are using to reference their, you see what I'm saying? So these studies come out, and then we make these assumptions. Now, have we tested all 7 billion people, 7.5 billion people on the face of the earth, and do we know that exactly 38% or 44%? No. You see what I'm saying? You just do epidemiologic data, you take large databases of genetic information, you test them for specific genes, and then you talk about what the ratio is. Does that even matter? No. The only thing that matters from an applicability standpoint is what the individual that we're dealing with is expressing and how we can use that within their current environment to maximize their response to the goals that they're trying to achieve. Okay, so Michael is RR, higher ratio of type 2 fibers compared to type 1 fibers is what it's suggesting. And then, they're trying to connect with the masses, right? This isn't made for, these types of reports aren't made for, this is where I'm going to finish the statement here. There is a gap in understanding between what this stuff is and what people's understanding of genetics are. Right? You all have the opportunity in this class and through this program to learn what the impact of those things are, So that, but they have to use some ridiculous language sometimes, like the RR is associated with a boost in muscle strength. Is more frequently seen in speed and power athletes. And that's actually not necessarily all that true, right? Because RX was across the board in that data, right? But we have this just assumption that, all right. But what is interesting is, you know, before Michael had some injuries, you were a power athlete, right? Weren't you a sprinter?
Yeah.
And a football player? Linked to higher average of testosterone levels, higher ACT3, protective against muscle damage. Now, what would be interesting, yeah, okay, right? So there's this CYP1A2 gene, which is very interesting. This is a gene for how quickly people metabolize caffeine. So we can get insight into that aspect. So Mike is a fast caffeine metabolizer. Now, how could we have tested this without knowing you were a fast caffeine metabolizer?
Drink some caffeine.
When?
Now.
No.
2 hours ago.
No.
No.
What? At night. And then see if what? Exactly, right? I mean, but people know some of this stuff, right? People know, like, I've worked with people that, like, if I eat a square of chocolate afternoon, I can't sleep. That's a slow caffeine metabolizer. Do you understand? So there's a range of the half-life of caffeine, but even in a fast caffeine metabolizer, half-life of caffeine is around 5 hours, 3 to 5 hours. Now, that's half-life, right? So it's going to be coming down at a particular rate. But a lot of people can have like a light cup of coffee after dinner and sleep just fine. Or have afternoon coffee and it's not an issue, right? Other people, if they drink even a soda, which doesn't have a lot of caffeine in it, at lunch, they can't sleep that night. Right. So I think this is really interesting. Rate of caffeine clearing for a 100 milligram dose. So that's pretty interesting. The FTO gene is often called the obesity gene. This is a gene that affects if you have homozygous 14. If you have the homozygous AA, you're more likely to be hungrier and have less suppression of hunger in response to meals. Right? So Mike says you have 2 copies of the TT, which is associated with lower weight, decreased appetite, and less loss of control when eating. It's quite interesting, right? So these affect signals that are what are called orexigenic. So you have orexigenic signals, which are signals that make us want to eat more, or you have anorexigenic signals, which are signals that want to make us eat less. Right? And these are regulated by gut peptides. They're neurotransmitters that are released from our gut during digestion and go and talk to the brain. It's sensitivity to different hormones. There's a lot of things. Those of you that take HWS 325, we talk about central nervous system regulation of appetite and food and satiation and those types of things. Right? Calories have very little to do with making us stop eating or feeling full. Right? There's a lot of factors to it. The example that I use a lot is things like if you completely stuff your face for Thanksgiving dinner, and then I sat down a plate of, you said, I can't eat another bite, and then I sat down a plate that had 500 calories of turkey and gravy and mashed potatoes on it, people would say, no way, and said, eat that in a half hour. People say, no way, I can't do it. But if I gave you a soda that had 500 calories in it and said, hey, just sip on this drink while you talk to people and try and finish it in a half hour, 45 minutes, people could do it, no problem. Same exact amount of calories. See what I'm saying? So the regulation of food intake is totally different, and it's strongly related to certain genetic markers. So people with 2 copies of the TT on average, less than 6 pounds less than those that copy the AA. And research has demonstrated that those with the TT have lower appetite and exhibit more control when eating, right? Super interesting. So you can look at the FTO, and then what they do here, which I give them a lot of credit for, is that they do give the citations for each one of the studies, or each one of the genes. And so what they're saying is, look, this is our team of scientists' interpretation of the literature that's currently available. We looked at these studies, we looked at these 21 studies, and we decided that those are the 21 studies regarding the FTO gene that can be interpreted responsibly in this way. So I give Fitness Genes a lot of credit for doing this, right? But now they have to translate it into lay speak so they can tell people about the implications of it. Yes, Mike?
I don't know. I've seen recent studies about, and heard different information about having certain types of foods after each other that kind of allow you to eat more. So like if you have some salty food or not just sweet food, you have some salty food.
Sure.
And then eat more salt or sugary food.
Yep.
I thought of that when you suggested the top after all of that hearty food. Kind of be hard to eat something.
Yeah, I'm not saying that it's I'm not saying it's single faceted. There's a lot of factors to it. That example is one that I commonly use when I'm giving talks, so because people can relate to it. Because people think that calories is what makes them feel full, and it's not. It's what the nutrient and what the signals are that tell us to feel full. People also don't have an appreciation for individuals that have certain characteristics that individuals that have certain characteristics that may put them in a position where they eat more or don't stop eating as easy as other people. It seems easy for those people that stop eating, and there's a divide in understanding. You say like, and so as a practitioner, we're training you as knowledgeable individuals in these types of things, right? And when someone tells you, I just have a really hard time stopping eating when there's food around. Like, you don't just say, well, get stronger, develop. Do you see what I'm saying? Like, there's actual reasons for that. And when you live in an environment where crappy, really pleasurable tasting food is around us 24/7, literally, it puts people with these types of genetic single nucleotide polymorphisms at a much higher risk for doing the things they're genetically made to do, right? The reason why they've been able to pass these genes along, or the theory behind the reason why they'd be able to pass these genes along, is because if the food isn't available, then it's not an issue, which is how the vast majority of human history has gone, right? It just sucks. Does that make sense? But now we have food availability 100% all the time, everything, right? But there's other factors to it. There's epigenetic factors to it. There's things that take place when a person is a fetus is developing in the mother's womb. There's a whole field of study called prenatal programming, which can demonstrate differences in things like health and obesity and weight outcomes in individuals based on a mother's diet and exercise patterns and even stress levels while they were undergoing the pregnancy. So, we don't understand all of these things, and it's super duper complex in terms of how, that's a technical term, in terms of how, thanks for that courtesy chuckle, Anna. She goes, yeah, so how these things all fit together is really interesting. All right, PGC1 alpha, does this look familiar? What is PGC1 alpha? It's the transcription factor that turns on the transcription for what protein, mainly? Don't look. Come on. PGC1 alpha, it's turned on by NFAT. NFAT is turned on by what type of exercise? What? Aerobic exercise, endurance exercise. What is the thing that we need for endurance exercise that'd be really good to adapt? What? What burns fat? What?
Mitochondria. You need mitochondria.
Yeah. What is the organelle that burns fat? Where is the TCA cycle in the electron transport chain? Mitochondria. We talked about this, right? PGC1 alpha is the master regulator of mitochondrial biogenesis. Not only does it signal for mitochondria to get bigger, it also turns on mitochondrial protein production and what other thing of mitochondria that we talked about? Mitochondria has its own what? What'd you say? Has its own DNA. How do we turn on gene expression of things of genetic material? We have to activate what? Keep going.
She said it.
Keep saying. Transcription factors. So PGC1 alpha turns on the transcription of mitochondrial transcription factors that turn on the mitochondrial DNA gene expression so that we can grow mitochondria. Master regulator of the mitochondria, right? So if you have a genotype for expressing more mitochondria, then that could be beneficial from endurance performance, right? So Michael, you're super, super unique. You have the speed gene and the endurance gene, right? But this is really useful information to know in terms of what your trainability is, what your response to training could be. So you have a high responsiveness to high training volume. You have responsiveness to both aerobic training and anaerobic training. You have, likely you have a higher percentage of type 2 fibers, which we already know because you're really good at sprinting. You've probably always been like one of the faster people amongst your peers. So, yeah, pretty interesting, huh? These are pretty cheap, I think. I mean, we count this for, they count this for a gene for health and fitness, but it just tells you what color eyes you have. Like, it doesn't give me a lot of good information.
You can tell just by looking at it.
Right? All right, some other things. Clock gene. I told you get to name it. If you characterize it, you get to name it. So this person decided that they were going to call the clock gene. So you have one copy of the night owl gene and one copy of the early bird gene. And people know this, right? Now, not if you, follow those hashtag grinders on Instagram that tell you that you need to get up at 4:30 every morning and that's how you can be, that's the only way that you can be productive. Right? That's not true. There are night people and in fact, one of the things that they've been demonstrating is that it's actually potentially increasing risk for things like weight gain and inactivity in young people, forcing them all to get up early and go to school early on the same schedule. And some people thrive under that scenario, and some people don't. And basically blaming that on a character flaw, we may be a little too hasty just blaming that on a character flaw. Interesting, huh? It starts to shed new light on, things that people think are just 100% in their control. Right? When you start thinking about it in terms of genetics and you start thinking about it in terms of epigenetics and environmental and these other things like mental, your mental approach and those types of things. But it does make people, this is not a platform for excuses though. That's the other thing. There are certain realities that you have to fit into. And people may be more or less talented to fit in those realities. But that's the way it is with anything, right? If you're faster, you're faster. You can't be like, well, I want to be in the NBA, but I'm not tall because of my genes, so give me an exception, right? Most of the time, it just takes what it takes. But if you have some understanding of like what you're able to adapt to, then you have some insight on like maybe what you've been trying to force yourself to do wrong. And if you accept certain realities about the hardware that you're working with, then you have an increased chance of getting responsiveness, right? So if somebody has 2 copies of the night owl gene and they know they're a night owl, but all they hear about is if they want to be a productive person, they have to get up early, and you're in a position as a health coach, a practitioner, a coach, these types of things, to say like, look, that might not be the best thing for you. Why don't we try and schedule your workouts around here and keep your mornings open while you're trying to like wake up and, you see what I'm saying? But people that say like, I don't like waking up and working out first thing, what do we immediately think about them? They're just not tough enough. Right? Or like, 6 a.m. weights or 5:30 weights as a coach builds character. Well, why can't you have 2 sessions and let athletes choose and then not judge them based on the one they choose? Right? It's like, it starts to get pretty interesting. All right. So what you guys are going to do is look through these. There's information in regards to all of these. There are things associated with, say, like B12 metabolism, so in absorption. There's things that are associated with testosterone levels. There's things that are associated with fatigue and things like how we process particular nutrients. And they take these outcomes and then throw them into things like this to say, for example, these lifestyle ones are kind of interesting. That you're likely to have good B12. You have increased need for magnesium in response to a heavy training load. That because of your high proportion of type 2 muscle fibers, you probably produce a lot of lactic acid. So things like lactic acid buffers like beta-alanine would be beneficial. But of course, beta-alanine, which is the thing that makes you tingle that's in pre-workout, you guys know what I'm talking about? It doesn't do anything pre-workout. You have to take beta-alanine on a regular basis for about 50 days before it builds up to the point in your muscle that it can affect lactate buffering. The tingling is a completely innocuous side effect that has nothing to do with performance. But some people like the tingling because they think it means they're like amped up for their workout.
So you can tingle for 50 days while it builds up.
What's that?
So you can tingle for 50 days while it builds up.
Yeah, so basically what you have to do is decide when you're going to take your beta-alanine based on, like when I've tried to take it, for example, this is purely anecdotal, I'm really sensitive to the tingling, like my whole face like feels like it's numb, and so I can't take it before I go to bed because I can't sleep, so I have to take it like post-workout, but it has nothing to do with enhancing recovery, it's just a time to get it when I won't be, but even then, I don't like to take it because I'm so sensitive to it that I'm like sitting over here trying to do emails in the afternoon, and I'm like, you're not shaky, it just feels like your skin is really dry. That's like, have you ever had that feeling? And I've had athletes that are like, man, I've been trying to I've gone through like a half a bottle of lotion since I talked to you, and I've been trying to figure out why. And I was like, your skin's not dry, dude. You're just feels like it because of beta. Okay, I thought that was funny. Anyways, okay. So, super interesting. Thank you for being willing to do this and willing to share your results. And what I want from all of you is that you go through this and you look at these genes and spend some time and spend some thought into how you would apply this if Mike was your, client. with whatever goals that they had. All right? I definitely do not have this gene for hypertrophy. You have 2 copies of the A allele, which is associated with normal levels of hypertrophy. Sorry, dude. But you can see, I mean, this is one of the reasons why we've talked about things like muscle size isn't the most important determinant always of muscle strength. Right? And there's limitations to what you can induce using natural means. Like, you could probably override some of this stuff if you were to take testosterone and a bunch of other, like, illegal drugs. But what's the point? Right? But in a lot of ways, it could be advantageous because you could get high training adaptations, respond to a high training load. You have 2 copies of the power gene, but you're not likely to get so big that you become not functional. So there's all kinds of cool interpretations that you can make. And what this does is it offers people's and clients like peace of mind and understanding about like knowing why they're doing certain things in certain ways and why they may or may not be responding to things in different ways, right? And it also provides insight in this idea of why somebody who says like, I'm going to try a vegan diet, and then they just get like completely shredded and have a great response to it, and then they write a book and go on a health tour saying everybody needs to become a vegan. It's just ridiculous, right? They are a responder to that particular type of thing, and there's absolutely no reason why everybody is going to respond the same way. But we see this logic all the time, especially in the lay, like in the blogosphere and the podcastosphere and the health sphere. And the reason why we have to talk about it is because you will come across people that say, well, I heard this podcast, or I read this article, or I did this thing. And those things a lot of times do have really good information, right? I'm not saying all podcasts are crap and all like swolgers on Instagram are like ridiculous, right? Those things have value, especially in promoting health and all these different types of things. But you can't expect it, like everybody wants to be the person that's right. And it doesn't work like that. And you know why now, based on your understanding of complex genetics and responsiveness, polygenic traits, environment, epigenetics, and responsiveness. You understand? That's super powerful to have in your toolbox moving forward. Okay, so that's what I want to talk about with this. For your write-up, access this on the Fitness Genes website. Go through it, get some insight about it. Show me that you're thinking about it critically. You can write up a little mock program, not like specific exercises, sets, and weights and things like that, but if you can just make stuff up. Do you have fitness goals you want to share with us, Mike, that people can use in context?
It's small.
Yeah, it's out. But this is good. Like, if Mike comes to you and says, I want to add 20 pounds of muscle in the next 6 months. I see goals like this all the time on dietary nutrition reports. And if you guys are coaches, you should be having like beginning of season questionnaires and off season questionnaires that have goals and goal setting and things like that. And people will say things like this, right? I want to add 15 pounds of muscle. These types of things. Like these are goals that are outside of people's control. And whether or not they get them is going to determine whether or not they feel like a failure or a success. This is why this is critical. If Mike says, I want to get swole, and we can have an honest conversation why that's not a great goal. But things like, look, you have a high ability to recover from exercise, so let's make a goal to exercise 6 out of 7 days and do at least two a days per week. That's something he can control. You see what I'm saying? That's something he can control. And it's something that you can track, because maybe that overdoes it. Maybe we're saying we're putting too much trust in this gene that says he can handle a high training load. So after 4 weeks of, after 4 weeks of training sessions, and so what would that be? 24 training sessions in 2 days, something like 36 training sessions in a month period. And he's fried. Then we got to take a step back. Do you see what I'm saying? But now you're like working together, and you're using information in a way and you're controlling the controllables, and you're not worrying about things like, you hear this all the time. I want to lose 20 pounds. I want to lose 15 pounds. I want to do this. Why don't we just work on being aware of why you may have some of the habits that you have, and get to exercising every day? You see what I'm saying? These are different kinds of goals. And when you can point it back and say, look, that's probably not going to work for you. You're really resistant to weight loss. So what we need to do to try and, we're not going to have that as a goal. We're going to have working out as our goal. We're going to have increased awareness, increased meal planning as our goal. Super useful. Okay? Super useful. Okay, cool. So I'm going to stop the record.